In this video, we're going to be going over the eMMC modules for Libre Computer boards and how to flash them in Windows. This is a picture of our AML S905X lip potato board. It features an eMMC connector slot on the bottom. This connector is a female connector, and it is different than the designs of other vendors. On the eMMC module, there is a male connector that is mated to the female connector. On the top of the module is the eMMC IC and the voltage shifter. These are additional photos of the eMMC modules. So in this video, we're going to be going over numerous topics, including how to flash the eMMCs. Now we're going to get into how to flash eMMCs. We're going to be introducing the Libre Computer eMMC Flash tool, or LEFT. LEFT is an image that is also integrated into the Libre Computer Flash tool, which is a Linux-only tool. So LEFT can be a standalone image that can be used also with Windows. We'll be covering how to use this for Windows and leave the Libre Computer Flash tool for another video. So here are the steps necessary to flash the eMMC in the fastest way possible. Additionally, there are optimization steps that you can take to flash eMMCs faster for bulk deployments. Now that we covered the basics on what everything is, let's get started using the left image to create a flash key that we can use to flash an operating system onto the eMMC of a Libre computer board. So here, I've downloaded the left UEFI image onto my system. I'm going to start flashing this file onto a USB flash drive that I've connected to my computer. Remember that USB drives can only be used with UEFI compatible boards. If your board does not feature a UEFI, please use one of the appropriate images and a micro SD card. We're on step 2, moving to step 3. Once the flash is complete, we're going to open Disk Manager. You can open Disk Manager by running disk mgmt.msc. So our flash is completed. Now we're going to run disk mgmt.msc. And here we have the USB drive that was flashed with the left. We're going to create a new simple volume, assign it a letter, and finish. This will create a volume where we're going to copy the operating system image into. So once the volume is created, we should be able to see the new volume. We're going to copy our image from distro.librecomputer. We're going to, for example, here, take the Debian12 base image that we've downloaded already and copy it into the new volume. And then once we copy it into the new volume, we can either rename the file into flash.img, or we can configure it via flash ini. I'll explain a bit. So for example, this is the Debian12 image that's being copied. And there are two choices. One, we can create a new file called flash.ini, or we can rename this file to flash.img. You can choose either choice. So the copy is complete. So, so we're going to edit the flash.ini and point the flash.ini to the file. So we're going to get the name of the file, F2, and then we're going to say image file equals the file name. This way we don't have to rename this file to flash.img. Flash.img can be compressed or uncompressed. The left tool will automatically detect it and decompress the file. Okay, now that we set up flash.ini, instead of doing the flash.img, we can eject the USB key and boot it on a Libre Computer board. So we're going to be using a Lafrit, the AMLS 805X AC, as a demo board. Make sure that you eject the image. If you don't eject the image, there could be data corruption, and sometimes Windows just likes to play games. Okay. Okay, so now that the disk is fully ejected, we're going to be plugging it into the Lafrit. I apologize for the video quality. The webcam is not focusing. So we're going to be plugging in the USB key into the board and then turning on power. So the USB key will boot on the board uh, if the eMMC is clean and doesn't have a bootable operating system. If the eMMC has an operating system already, you need to disable the booting from MMC in the bootloader. I'll give you instruction that as a supplement at the end of the video. So this is the board booting from the image that we just created. This is booting the left tool, and then the left tool will detect the image that we need to flash. From here, it says the source is the SDA2, which is USB based, and then it has a custom parameter, which is what we provided in flash.ini. So the image file is this, and then the format is automatically detected. It detected that the image is XZ compressed, and then it's using a decompression command to flash it to the eMMC. So XZ is a high uh, compression ratio compressor. It's also very slow. So it on a Cortex A53, it maxes out at about 10 megabytes per second, which is much slower than what the eMMC is capable of writing at and what the USB is capable of reading at. So the USB is capable of reading at around 40 megabytes per second, and the eMMC can flash at up to 150 megabytes per second. What you can do is separately recompress the image using ZSTD, and we'll have a video on how to do that at the end. And please note that if you have a board with micro SD, we recommend using micro SD because micro SD cards read faster than USB 2 flash drives. But if you have a USB 3 board like the Alta or the Solitude or the Renegade Elite or the Renegade, we recommend using USB 3 since that's faster than micro SD card potentially. If you use a USB key, that is fast. So here it's flashing uh, the image to the disk, and then it's giving you a status update roughly every 15 seconds. For this image, it is around 2 gigabytes. So left also has a feature where it can expand the last partition for your custom images. So you can drop a custom image into the new volume that we created, and then it will flash that too. In flash.ini, if you create a new line called image underscore expand in all caps equals 1, it will read the last partition and then expand that to the full size of the remaining space on the disk. So the flashing has completed and it's ready to reboot. So you just press any key on the board to shut down. And then once it's shut down, we're going to remove the USB key and then turn the board back on. So this time the board has booted from the eMMC Debian 12 base. So you can take this USB key and you can plug it into another board with eMMC and it will flash that too. So there we have it. Um, this is Debian 12 base running on the Botfreet from the eMMC. I'm going to put some further addendums to the end of this video. Now that we know how to flash the eMMC, I want to demo how to deploy the operating system faster to the eMMC by recompressing the image using a faster compression method. So Facebook created a compression standard called ZSTD, and there is a project for Windows called pzip that supports creating ZSTD archives. So what we're going to do is we're going to download and install pzip, and then extract the image from the XZ compression. Now that we've extracted the image, we're going to recompress it using pzip to the ZSTD standard. we just select ZSTD in type here, and then the default compression level of 3 is sufficient. As you can see, compressing using ZSTD is very fast, and the file size is 100 megabytes bigger than the XZ compression. So we're going to take this file and then copy it into our USB key that we made previously into the new volume. As you can see, the USB 2 is limited to around 40 megabytes per second. So this is something to take in consideration when you are deploying onto the board, that the read speed of the source. And just to demo a different path, before we use flash.ini to set the image file, this time we're going to use the other path that's available in left, which is we're going to delete the previous files, and then we're going to rename this file to flash.img. Make sure you have the file name extensions shown, right? Because if you don't have that shown, sometimes the file extension will stay hidden and it becomes flash.img.cst, and that won't work. So again, once we finish that, we're going to eject the drive. Now that I've ejected the drive, I'm going to install it into our SBC. Remember, previously we've already installed the operating system on this SBC, and thus it will boot to that by default. I'm going to show you how to configure the bootloader or interrupt the bootloader so that it boots off USB. Now we apply power to the board. So I press any button on the console and it goes to the U-boot prompt. We must type in set boot targets USB and then boot. This will prevent the board from booting into the operating system that's already in the US installed on the eMMC. So now we're booting off the USB. And it detected that the new image format, which is flash.img, is ZSTD compressed, and it will decompress using ZSTD before flashing it onto the eMMC. So as you can see, ZSTD is flashing at 48 megabytes per second instead of 10 megabytes per second with XZ before. XZ compression is very effective at making small files, but the decompression is very slow. So for mass deployments where you're deploying hundreds of boxes, ZSTD is ideal for deploying the image faster onto the eMMC. We were able to deploy the image in 54 seconds, which is several times faster than before. And then we're going to shut down the system. And then we're going to boot the system again. And it's booting Debian. a clean flashed Debian image. So we were able to speed up the deployment by almost 4 times by recompressing the image. So if you're deploying a custom image, this is ideal. And you must take into consideration what compression format that is being used when you're doing the redeployment. So this is a new installation of Debian. As you can see, I have to reset the root password. So that's it for this video. If you have any comments or questions about Left, the Libre Computer eMMC Flash tool, please comment below. We hope this infrastructure demo was useful in helping you understand the software infrastructure and deployment infrastructure of our platforms.